Alright, thanks for watching, and today I would like to give you another quick example of a line integral. So let's calculate the line integral of the function y with respect to ds, where c is the line from, let's say, 2, 0 to 5, 4. And again, what does that calculate? So first of all, maybe let me draw a little picture. In other words, if you have, let's say, the line from 2, 0 to 5, 4, maybe here, connecting it that way, then what this does, it calculates, if you want the area under the function 1, so think of it of a surface, but over this line C. So maybe in 3D perspective, what it looks like, this is C, this is maybe your function y, which I'm guessing is probably flatter than that. And what it does, it calculates the area of that fence under C, so over C and under that line. And it's a very powerful thing. For instance, in physics, it calculates the work done by the force y on the curve C, or it calculates the mass of the wire C with, if the density is y. But as I said, today, just a very quick example. So the way you do this, again, you first draw the picture, then you parameterize. So let me quickly remind you how to parameterize a line. X of t equals something, and y of t equals something. So you start at the point 2, 0, and you end at that point 5, 4. And then, of course, the debate is, do you put t or 1 minus t? Well, notice, at 0, you really want this to be 2 and 0. So it cannot be t, because t would mean this disappears at 0. But we don't want that. So that's why we put 1 minus t here and 1 minus t here. But this we do want to disappear at 0. So that's why it's t here. And I think we can just simplify it. I believe it becomes 2 plus 3t. And then the other one just 4t. Then t is between 0 and 1. You parameterize this, and lastly, you just use the formula which is given as follows. So integral over c of y ds is just integral, again, from 0 to 1 of our bounds of, again, y of t, and then this weird factor ds, which is just square root of x prime of t squared plus y prime of t squared dt. And again, in another video, I will derive that. And therefore, all you need to do is to use your formula for y and use that formula for that ds, and then you're done. So what you get is integral from 0 to 1. So y of t was 4t. And then square root of the derivative of this with respect to t is 3, so 3 squared. Derivative of y is 4, so 4 squared dt. And the cute thing is, this is a Pythagorean triplet. So, it's like having a baby almost. You have triplets here. And then this becomes integral from 0 to 1 of, I think, 20t dt. And then I believe an antiderivative becomes 10t squared from 0 to 1. And then in the end you get 10. So that is the area under that line and over that function. And I know there's probably an easy way to do it geometrically, but for here I just wanted to illustrate that formula. And I promise you next time I will do the derivation of this. Alright, I hope you like this. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.